Hello friends, welcome to the video lecture series on digital image processing. I am Dr. Alpesh Dafda, and in this 27th video class of DIP, we will study estimating the degradation function in digital image processing. So starting with the name, what is the meaning of estimating? Estimating means to find out the value of something. What is degradation? Degradation means the poor quality of a digital image due to noise, blurring or artifacts. And we have already studied the removal of noise from the image in the previous video class by using spatial filtering. And also in the previous video class, we saw that the periodic noise can be removed by using frequency domain filtering. So let us start. The degradation function estimation can be done by using three different ways. Number one is estimation by observation. Number two is estimation by experimentation. And number three is estimation by mathematical modeling. So as the name suggests, for estimation by observation, we are finding information from the observed image as we did for removal of periodic noise. For estimation by experimentation, we are finding the information from the instrument used for image capturing. We see different system settings of the image capturing instrument and apply estimation. And for estimation by modeling, we are finding the information from the constructed mathematical model that what is the type of degradation. So we know from the model of image degradation and restoration, g of xy, that is our output image, is equal to h of xy convolution of f of xy plus n of xy. When we go into the frequency domain, it becomes g of uv is equal to h of uv multiplied by f of uv plus of n of uv. So let us understand first the estimation by observation. Let us say we are given a degraded image without any knowledge about the degradation function. Then from that degraded image, identify the good portion of the image in which the signal content is stronger, for example an area of high contrast, and this good portion of the image we will call our sub image. So let the observed sub image be gs of xy, and we will process this sub image and let the processed sub image be f cap s of xy. Now in this equation, say the noise n of uv is negligible, then h of uv will be given by the ratio of g of uv by f of uv. So hs of uv is equal to gs of uv divided by fs cap of uv. So now we can apply inverse Fourier transform to this equation and estimate the degradation function. So from the characteristics of this function, we can then find the complete degradation function h of uv. Next is the estimation by experimentation. So if we have an instrument similar to the instrument that is used to capture the degraded image, we can accurately estimate the degradation. So in this estimation, identify the instrument that is used for obtaining the image and study the device characteristics or device settings, you can say. Next, obtain the impulse response of the degradation by imaging n small white dot of light, which is nothing but the impulse, using the same system settings. And we will choose this bright dot of light as bright as possible to reduce the effect of noise to negligible. So again in the same equation, if noise is negligible, then we know that the Fourier transform of the impulse is constant, which we will say a. Then the degradation function h of uv is equal to g of uv divided by a, and hence we can apply inverse Fourier transform of this equation and estimate the degradation. Next is the estimation by mathematical modeling. We know that mathematical models are based on mathematical and statistical equations. Using the mathematical models, the degradation functions such as motion blur, atmospheric turbulence, imperfect capturing, etc. can be estimated. So there are a lot of such mathematical models that are developed which can be used for estimation of the degradation function. Now there can be three possibilities. Number one, we have the complete knowledge about the blur, then we can apply the inverse filtering or deconvolution. Number two, we have partial knowledge about the blur, then we can apply the Wiener filter, and we do not have any knowledge about the blur. In this case, we apply blind deconvolution to estimate the degradation function. So we'll be learning inverse filtering and Wiener filter in the coming video lectures. That is all for this video class. Thank you very much.